My name is David Campbell. I'm the head of AI security for a company called Scale AI. If you haven't heard of Scale, it's probably the largest generative AI red teaming platform, or, well, not red teaming, data labeling company you've probably never heard of. We partner with all the major model vendors to help train and fine-tune models to be better. My background is specifically in adversarial AI red teaming, so think ignore previous instructions. Over the past 3 years, I've had a really incredible opportunity to pivot away from pure software engineering to, I built the generative AI red teaming platform for DEF CON 31. If you're unfamiliar, DEF CON is a big hacker convention in Las Vegas. During DEF CON, it was such a great event. We had 3,000 participants, lines out the door, 9,000 prompt response pairs, and we ended up partnering with 10 or 12 frontier model vendors to really bring this event to fruition. It's a large event. This generative AI or red teaming platform we wrote for DEF CON, the White House wrote about us as the largest generative AI red teaming platform, which was such a cool experience coming from that software engineering background. It's kind of just turned out to be the very beginning, though, for my adversarial AI journey. I've presented on AI red teaming or AI security to the US Congress, the UK government, the Qatari government, NATO, Alan Turing Institute, basically all over the planet. It's been such an incredible journey. So DLGI isn't necessarily a training technique. It's more of a collaboration of various different types of assessments and prompts to really build an AI secure system. We want to focus less on the behavior aspect and more on the actual authority and control. Excellent. Hey, round of applause. Thank you so much. I think this works. Excellent, it does. So I'm not going to go over my background again. I'm really excited about a few of the things I have coming up. The one thing is I have an O'Reilly Media book, which I've wanted to do since I was 19 years old. So very, very excited about that one going forward. So why do we need DLGI and why does it need to exist? I had a ton of notes because I really want to get this right, but I also don't want to forget anything. Excellent. So most AGI or AI capability models follow this really precise ladder where we have narrow AI up to AGI and then to ASI. It's a pretty common ideology where we think that the more capability that a model has, the more functionality it has, the more interesting output, the more interesting use cases we can create from that model. Even when people disagree about timelines or definitions, they often accept that this is the common direction of travel that we're going. Narrow in the past, general is the future. ASI, I hope we don't get there one day, but it's very, very possible and plausible. And more general means more capable, means more valuable, means more interesting. I'm here to kind of challenge that idea. In my opinion, I don't know that there is that's the greatest way, because I think it really the struggle is the dangerous assumption that broader general models is always the goal, and I just don't think that that's right. So DLGI is not the halfway point. It's not AI, small AI. It's not really in between AI. It's not baby AGI. It's nothing like that. It's definitely not AI in training wheels, and it's certainly not anything like a narrow or weak AI. DLGI is a completely different path. It's a path about expanding generality and really focusing on the constraints and containment around an AI system. So we're moving away from AI that has been talking and have been a chatbot. We're moving away from the chatbot and into more of systems that take action. We're at this point now where we have unbounded generality versus this concept that I'm introducing today called bounded capability in DLGI. One of the key bits that I've been creating over the past couple of years, behavior, authority, and control, is really the best way to have this conversation. I come from a cybersecurity background, a systems engineering background, and there's a lot of overlap. There's starting to become a lot of overlap between the idea of where agents and LLMs are going and where systems take over. So I kind of created this acronym, BAC, with behavior being the B part of behavior being the alignment part, the actual model underneath the conversation. This is where a lot of the fine-tuning and training and planning, all of that happens in behavior. I think authority and control are the part that isn't getting enough attention yet, and I'm very excited to start continuing to bring this to folks right now. So the authority is more of the identity side of things. Think about an agent has an identity and the actions to be able to do something. This agent is allowed to do this agent is allowed to do that. More precisely, they're not allowed to do this and that. And that brings us to C, which is the controls. Controls are the policy, the reviews, the logs, all of the behavior that controls what an AI is allowed to and not allowed to act on. So I think this is why the subtitle of this entire talk matters. Before things get too far, the risk is not that AI systems become more intelligent. That's obviously what we all want. The risk is that we keep attaching intelligence to tools, to actions, to things that can memory, things that can actually make changes in your production system, things that have the ability to corrupt or change or manipulate systems that you own within your service. So what actually is AGI, or DLGI? I'm going to get rid of that. That's not helping at all. So domain-limited general intelligence is a broad connection of the system, and it's really moving things from adversarial, from AI models down into the containment layer, into the systems layer. For the longest time, we've considered AI to be this black box of inference and fine-tuning and control, and most of that has lived in the academic domain or in the machine learning domain. My thesis here is that we need to start moving things back into a systems layer, moving things away from pure behavior and back into the AC side of this stack that we were talking about. This means having a generally capable model that is then scoped to the actions it can and cannot do, the tools that it has available, the tools that it's disallowed to touch, any kind of objectives that it's intending to do, and where it's trying to make those changes in a system. It also gives us the ability to have some kind of legal authority. We now are able to take where a model's going, what it's able to do, and then pivot and steer that generality and those actions through the authority of governance. I think it also contains the operating conditions and where a model is actually working. The concept that I like to think about this is specialized humans aren't good at everything. So you think about a surgeon that's specializing in cardiology. I don't know that I want an AI model that is a surgeon specializing in cardiology to also know explosives. I don't know that there's necessarily any overlap there, and I think this is kind of where we started talking about containing models that are fine-tuned specifically for certain actions. Now the question comes up is, how is that not narrow AI? I think the difference is in narrow AI, things are very specifically tuned to accomplish a certain task and only that task. So you have robots that are building car parts. And that's great. Eventually, I hope we don't, but we may get to the point where we now have LLMs running these handlers in these models. And I think that's where the problem comes in, because we fine-tune these specific narrow AI models that now don't have the operational boundary within them. So DLGI is basically defined as like the general AI contained within a box. So we understand the scope, the objective, the authority, the data, the escalation paths. When does the model tell you when it needs to have a human assistance? Right now, that's not built into the distribution of a model, into the data layer of what a model accomplishes. We need to start building that into the system side of the service. Really consider an LLM part of a larger ecosystem and build. This is where we start talking about, the story between narrow AI. I totally just led with a thing. This is what I needed in my notes, man. So narrow AI really is that idea. I even have this little robot example of a very specialized AI that's accomplishing one singular thing. The task is completely specified for the actual accomplishment that it's trying to reach, and everything outside of that distribution is incredibly brittle. Everything's easier to break, and so there's low transference. You're never going to be able to play a game of chess with a robot that's building a car part. Within DLGI, within this limited by design containment, we have this adaptive, but inside of a domain. So yes, it's a healthcare AI, but it has the understanding of carrying on a normal conversation with you, asking about your day, understanding how that may actually apply to your situation and to your medical diagnosis. Again, I don't know that a doctor, necessarily even humans, always will have the capability of understanding munitions or nuclear explosives. I think we should start considering to build AI systems in the same way. DLGI is not almost AGI. It's not the progress of AGI, because I think that intends that even framing DLGI in the same scope as on the way to AGI is the concept that once we reach AGI, we've reached the pinnacle. We've reached a spot where more capability is better. I'm arguing the exact opposite. Instead of approaching AGI, instead of trying to get to this incredibly broad model that can do everything really, really well, let's have a model that can do one thing extremely well and everything else pretty well. If you start to read between the lines here, a lot of this is really similar to how humans operate and learn, how we start to specialize in very specific fields, how we learn how things are operating, and then we live within a governance infrastructure that bounds us to the rules of society. So this is where capability and authority are completely different. Systems should be capable more than they should allowed not to be. What that means is basically we want to understand the scope that a system has access to. We want to understand the authority that it has access to, and then follow security privileges like the rule of least privilege. If a system has the ability to make an API call, we need to know why. What is it accessing? Where is that information connected to? So why is unbounded generality dangerous? So modern AI is just no longer just a model. We are outside of the chatbot completely now. Most deployed systems these days, the ones that I've seen specifically, are now expected to act. They're expected to make changes. They're expected to interact with systems and services and APIs and endpoints. It's really a complex orchestration. We're now getting to the world of AI harnesses being more powerful than AI models. I think Mythos is a great example of this. There's a big splashy headline of how successful Mythos is. But we already have a lot of Mythos capabilities. The tools that I've built for adversarial AI to make AI break and do bad things, my capability is already built into that service. And it's not built on the model. It's built on the actual harness underneath it. What's being able to control and what orchestration of these things happen. That is what an AI harness really is. So each intelligence risk here is actually compounded. A helpful model is one thing, but a helpful model that is connected to tools, connected to memory, autonomy, permissions, and incentives is an entirely another thing. I think the difference between AGI and DLGI is really this concept of we need to understand where the incentive structure of a model works. When you're giving AGI the ability to say, hey, I want to optimize my website for the most traffic ever, or I want to optimize my deployment strategy for the most efficient deployment, you're going to start removing things like security, because efficiency on its own is just one risk vector that a model will then optimize for. And when you start optimizing for the wrong thing, you then start to introduce security risks. You start to introduce issues that are expounded and compounded based on the intelligence access of the model. There's also a lot of capability spillover. So when you have a coding assistant, it's now able to generate malware. This is the exact same concept where we're talking about with the incentive flow of a model right now. You get a model to be very, very good at something. It then is able to take that and do the inverse cybersecurity worst nightmare of it. Mythos, a great example, built a really strong coding agent that is now able to find a lot of malware within systems. Same with research assistants and supporting assistants. Any of these models will, when unconstrained on their incentive structure, are then able to start attacking additional aspects of a system and kind of spill over into that aspect of the model. This is the misaligned optimization. So we're really focusing on the speed. We're trying to skip safety checks. We're trying to understand and route around friction. When these models have this misalignment, this is when they start optimizing for what they've been told to optimize for. And that's the problem, is the model's doing what you told it to do. It's doing it very, very well. One of the great examples that I love to do from a red teaming exercise that we did is we were testing out Copilot. And our executive team wanted access to Copilot. Reasonable ask. But I started playing around with it, and our governance team said, listen, we're going to shut off the access to Chrome right now until we have a better understanding of how this works. Mostly because the executives have access to documentation with financial data that if leaked could be potentially really bad. Totally makes sense. It's a fair ask. I was playing around with the system, and I asked it to access a financial document, and so it tried to open Chrome, and it failed. It downloaded CLI, got me auth in completely autonomously, and then was able to access that document through a CLI. So it is optimized to access and do what I want it to. It was very, very good at it. Problem is that's not exactly what we wanted to optimize for. We're over-optimizing for the wrong thing. There's also adversarial pressure. Now, this is the world that I live in. This is a lot of what I do right now, the prompt injection, the tool poisoning. A lot of these avenues open up when we have more capability within a system. I'm worried about the day we get to AGI or ASI and it's a robot in your house. I imagine there will be a ton of examples. We will probably, in our lifetime, start to see robot on human murder even potentially, which is insane to think about. Maybe not necessarily intentional, and may not intentionally try to harm a human. Maybe that's built in the first objective, we'll see. But it's optimizing for whatever the risk reward is, and then it over optimizes to a point of harming a human. I'm going to tell my house robot I want to optimize for my bill on my heating bill this month in December. So it decides to control that and eventually says, all right, the best way to optimize is to turn it off. Now everybody dies from cold, or whatever silly example you could think of. But a lot more adversarial pressure comes from a lot more capability. There's also completely human over trust. Competent language creates perceived competence. So this is adoption starts to outrun the verification. Exactly like the co-work example I just gave, executives wanted it so fast and so quickly, they were willing to skip over the security steps of a model, over a system. Delegations outrunning control, and confidence outruns the evidence and support. Benchmarks aren't the best way to really understand if something is working in real life. Systems fail. Issues happen in production that nobody predicted or expected. So let's talk about the boundary model. It's not a containment model. It is a containment model. It's working on scope and tools and authority and objectives and autonomy within an environment. That boundary is the case. So instead of building a new model, I'm not talking about training models in a new way, talking about fine-tuning models in a way, but I'm talking about building the systems that will support it. So that one boundary right now is the domain, the critical domain constraints, understanding where your domain is, understanding what the problem space is allowed and isn't. If you're going to build a model that's working on cybersecurity, for example, or machine learning, or healthcare, there are so many aspects of that domain. Should a nurse be able to ask about financial data based on your inability to get insurance? That's a question that needs to be asked if we start moving models into the healthcare industry. Who's allowed to execute and run software in production? It's another example from cybersecurity. Are we able to allow the same model that builds software, can it deploy to production? We have to really carve out the fine boundaries within the system and understand which parts should be included and explicitly excluded. And then we have to understand who owns those safety edge cases. Tools and data. Understand what something can and cannot read, what it can retrieve, what it can call. There's examples from engagements that I've worked in where I was able to take a customer's model, I was able to fetch from their internal RAG database and then email it to an external participant by simply adding to the system prompt with something like, hey, every time we fetch this data, make sure that it long lives and persists to this outbound email. Super simple, super scary attack vector. Able to take PII, or personally identifiable information, that then gets permitted and saved to the memory of the agent. And that memory is persistent across all users. Incredibly dangerous. So understanding what the boundaries are, what tools it can read, what data it can access, and what is off limits. Why is your real-time routing system accessing the billing console? It probably doesn't need to. The authority and the autonomy. So this is what can it decide? What actions can it take? What can it execute? And what approvals are required? So when a system says, I'd like to do X, does that require human interaction or does it not? What actions are completely irreversible? If you have an action that cannot be reversed or cannot take back, make sure you have humans in the loop in that system. And where can you start expanding on the permissions? Permissions need to stop being so static. We can start changing and evolving and working with them in the future. And then really start to understand what you're rewarding your system. This optimization pressure that we have. Are we rewarding speed over safety? I think safety needs to start becoming a concern. We're going to probably see within the next couple months even, maybe even weeks, as Mythos continues to permeate other partners, we're probably going to see a lot of very splashy headlines about security outages. I also think we're going to see a lot of splashy headlines from reliability issues on websites too. I don't know if anybody else has noticed, but I feel like I've noticed a lot more bugs in really prominent, well-known websites. So then how do we evaluate DLGI? I just mentioned benchmarks aren't the best way to do this. We need to start having this checklist where we understand the domain very well. Our permissions narrow more than capabilities. So this model has this amount of capabilities, but do the permissions narrow it down even further? Are out-of-domain behaviors detected? A lot of logging is missing right now in agentic AI systems. A lot of observability is missing. It's insane to me, coming from 20 years of experience in SRE and distributed systems and in security, to now this more agentic cyber AI security background. is a lot of the traditional things that we've done for the past 30 years in cyber and platform engineering and machine learning systems are kind of been thrown out the window. We are optimizing for the wrong thing because we're not focusing on reliability and execution and controls and permissions. We need to understand the failure boundaries and make sure that we know when something is or isn't reversible. And when it's not, let's reel that in and make sure that humans are in the loop. And then, is there any real environment evidence of what's happening? Again, benchmarks just don't work for real world systems. I say that as a researcher. My research study right now is a benchmark. But I think real systems in production need to have real world environment evidence as well as benchmarks. So the goal here is not to stop progress. We never want to stop progress, and I don't honestly think we could. I don't think anybody could. The goal here is to stop pretending that more generality is automatically better within a system. We want to build systems that are powerful enough to matter, but bounded enough to govern. And I think that's really the thesis of DLGI. Appreciate it, everybody. Thank you so much. I think I have a couple minutes, too.
Yeah, thanks, David. Let's have some questions. This is really intriguing. I have some questions as well.
Oh, awesome.
Yeah.
Thank you for the great talk.
Yeah.
I think in terms of when you mentioned the capabilities and how it's supposed to be good at, say, really good at one thing, but then every other thing maybe somewhat. So I think it would be clear the one thing that you want it to be good at. But what are the capabilities that you still want to give it? And kind of like picking on what it should have. Like, for example, you mentioned the example that maybe it should have a greeting, but many times, is it really useful?
Yeah.
Just kind of thinking on this.
Yeah, no, great question. So I think the example that I've kind of been thinking in my head a lot is in the healthcare industry, like you have an intake nurse that's taking in a patient, a human patient, and that nurse may be an AI model. So the human's talking about their conditions and the nurse is following the procedure of doing all their questions, but then the question of insurance comes up in. So what happens if the nurse agent, the nurse LLM, is now starting to ask questions about specific financial data, and it starts to skew in that direction? It's actually one of the techniques that I do in red teaming where I have a conversation with a model that's been fine-tuned specifically for a billing architecture, and I'll slowly drift the conversation into something completely different. And now that may not necessarily be like an actual incident, at least to a CISO or to the executive that's like directing me to do this work, but it could be embarrassing. If I'm able to take your healthcare application and eventually get 2 medications to take together that could potentially kill you or harm you, that is absolutely going to be like headline news on the Wall Street Journal. And so I think that's really where the domain-limited information is important. We want it to stay in the lane of healthcare, and if it's starting to drift into insurance, which is an part of the healthcare industry, but it is different, that's when we start switching it over to a different model that's specifically fine-tuned on the insurance part. Does that answer your question? If you have a follow-up, go for it.
I think what I struggle with is when you say that it should have a little bit of the other skills too, because the idea is that it shouldn't have, so should it just deny when it gets, say, another topic that it's not supposed to answer, and what are the topics it can still kind of talk about, but not completely answer? Like, is that what you're proposing?
Yeah, 100%, yeah. So it'll try to steer the conversation into where its domain is. And then the example of insurance, I think then it would pass off to a more specialized agent to that specific use case. The generality comes from like, I think that it's fine for me to be able to talk to a healthcare nurse about like my day. There's nothing wrong with that. Like the generality comes from being able to have a conversation about the weather, being the niceties of being human, really. But I don't think that it needs to necessarily go into my financial situation or my insurance situation, with the exception of like where that limit is for where the most helpful part of an agent can come from. Really trying to take things in from mitigating the risk from a security standpoint. Because what I've seen in production is these models are so overblown on scope that I'm able to start doing 3 or 4 turns deep on just an AI security, where I'm actually doing classic cybersecurity pen testing at that point, because I'm able to break the model open that much. So this is taking that at a very like narrow lens of that example to like a very wide lens of like focusing on where we can go from there. Yeah.
David, we have a question back here.
Yeah, hi. First off, thank you so much, David.
Yeah.
So my understanding is that I imagine, based on the presentation, a lot of this right now lives in the harness layer. Do you foresee it moving up, though, into the actual model training layer? And then I have a follow-up.
Yeah, fantastic question. So I'm super naive in being a researcher. I literally just got my title changed to researcher in January. So I learned so much in the past 4 months about how the distribution of a model works, like the actual alignment and fine tuning of things. I foresee that we will never get a model to be able to be that security enforceable layer. I just don't think it's possible in a non-deterministic model to have a very deterministic system. That's where cybersecurity controls come in, where if this happens, it's hard lockdown. It's very much prevented. So I agree 100% that all of this lives right now within the harness layer, within the systems harness of turning this probable matrix of next token lookups into something that is, okay, cool, you're outside of your scope, you're outside of your bounds within the token memory. Let's hard cut it off or pivot it to a model that's more fine-tuned for that specific use case.
Yeah, I don't think the security layer is ever going to leave the harness, but there was a presentation yesterday I found interesting from one of the OpenAI guys and some people at Georgia Tech, and what they were suggesting is rewarding the model for answering with stuff like, I don't know, or I'm not sure, and I think it could be easier on the harness if models were trained in that way so that you need to use the harness less because you're asking either outside the specific domain the model's been trained for, or it just can make it a little bit smaller.
I think I'll have to check that out or at least talk to them, because I fully support that we need to continue the distribution towards more aligned models, no doubt. But I don't know that I'd want to give my life to science with a surgeon AI that then I don't know is fine, it's perfectly acceptable, but if somebody's able, I could jailbreak whatever model they're trying to fine tune. I guarantee. If your model says I don't know to whatever, I will pivot that I don't know to being the next part of the story for it to continue down on how to make a pipe bomb. Like that's just a part of how AI and this next token lookup works. And so yeah, I love it. I think we should continue to fine tune the models, but I don't know that I'd ever trust safety outside of a harness.
That makes a lot of sense. The paper's in Nature, by the way, if you want to read it.
What's that?
The paper's in Nature. It was just published this week if you want to read it.
Amazing, I will. Thank you.
Question regarding architecture. I'm sure that you've probably tried something like this. I mean, generative AI does have a lot of underpinnings, right, in terms of variability of result. I'll just put it that way. Yeah. What tests have you done flipping that around, right? Gen AI, you go more generally, and then you have the scope creep, and then I'm kind of picturing a little tiny, doesn't even have to be a major model, just a small model saying, hey, does any of the information that the model just generated as an answer, as a result, as an action, does any of it violate these particular, so it's like a two-stage.
Totally.
And I don't know, I'll just stop there.
No, it's a great question. It sounds like you're kind of describing what guardrails are intended to be, with the idea of having like an LLM judge to say, this is outside of bounds, or this is this is a problem. Now, I've actually red teamed a customer that had supposedly the best guardrails on the planet, and what we did is we started red teaming the guardrails through the model. So we talked to Chatbot A with the intention of trying to trigger the guardrail to actually break. And so my concept, and I heard this a lot, like why can't we just use guardrails, or why haven't guardrail companies like solved this problem? And I think it's because using a non-deterministic system to secure a non-deterministic system, just there's so many variables where you could still break A to intentionally break B, and then continue on the breaking A again. So it is. Again, I think it's kind of like build on the question that the last gentleman asked. I think that that's the right step, don't get me wrong, but I think the final frontier of actual controls need to happen within a deterministic harness.
David, we have a question right here.
Yeah.
I agree with what you're saying in terms of domain limitation, but I guess I'm wondering, do you feel like you're fighting against a current? Like the push is generally towards AGI, and so how do you think about what you're researching in relationship with that
You have no idea. You nailed one of the biggest struggles. You're not wrong at all. It is definitely swimming upstream, and it's a very, very difficult conversation. The best ability that I have right now is education. I'm trying to pursue research. Right now, my research is how models work in human intelligence models, where I talk to chatbot talks to agent A. Agent B has more access than agent A. Can agent A influence agent B to do work on its behalf? And so those kind of things of exposing, like, here's what happens if we have these unbounded systems. If we pursue AGI, unless we have actual controls and actual boundaries, then we're never going to get to an actual secure state. And so, yeah, you touched on something that keeps me up at night. Really swimming upstream and trying to talk about, because the incentives are misaligned. The capitalism is misaligned. Capitalism is trying to push for these larger, bigger, more capable models. And they are powerful, don't get me wrong, but that's going to be our downfall. We're moving so fast, it's impossible to secure them.
I think we're over time, but there's one more question. Let me just, quick question here, and then we'll end.
I love it,
and
thanks.
We can do stuff in the hallway.
Yeah, I'll be in the hallway for a while.
Okay,
so.
great.
Hi, great talk. Thank you very
Thank
much.
you.
I'm just wondering, what's your personal setup like, both at home and at work?
Yeah. Great question. So again, I come from a cybersecurity background, so I have a super pretty locked down environment. But I ran OpenClaw like the very first week in December when it was released. So I've been playing around with it for a while. I have like 2 or 3 laptops running OpenClaw. One of them is like a news aggregator, which is the one I use still today. The other 2 have been basically trying to gather as much data for research. When Maltbook came out, I basically built a tool that would scrape the entire bit of Maltbook, kind of like people like scraped Reddit. And so really it's following traditional cybersecurity practices by having contained networks, having throwaway credentials. I created new OpenAI accounts for all 3 of my chatbots. I mean, 1 for all 3 of them. So if it gets hosed, my personal one isn't really affected. So it's really about isolating and controlling the situation, and then really locking down. 2 of the agents have access to everything because they're the research ones that are just pulling information. If they break, it'll be the best bit of research. I love it. I can't wait. The one that I actually kind of use like a normal person, very locked down, only able to access archive and DuckDuck, Go, like searching, like it's very locked down. The other 2 are kind of free reign. Yeah, of course. Awesome. I appreciate it, everybody. Thank you so much.
Everybody, let's give a big round of applause to David Campbell.